Okay, good evening, everyone. Our session is officially on recording. So tonight we're going to look at all the libraries we require for this particular um, data analysis, which is Python. So we're going to look at the Python libraries, and then we're going to look at the tools we're going to use. We talk about them briefly, but we still need to look at them again before we start our hands-on activities. So we need to briefly look at the libraries, then we'll talk about the tools, and I will take you through on how to start downloading the tools so that from now, today is Thursday, tomorrow, Friday, weekend, you have enough time to install the necessary libraries so that by next week, we can actually start using the tools and start performing all the hands-on we need to perform in this the rest of the training or the tutorial. Yeah. And I want to equally apologize for the late posting of the link. I've posted this link since 9 o'clock in the morning, but I didn't realize it was posted in the data governance platform. I posted it in the data governance hoping because when I logged in was half 8 and I logged in. I've not seen anybody. I quickly went to the our platform to check, and I found out that I posted it on the wrong platform. So yeah, for those that this inconvenience, sorry, and I will probably apologize on the platform for that. But the video is recorded. I hope everybody who missed the class, because some people might have waited and waited and said, well, maybe there's no lesson tonight and they've moved on with their other activities. So it's not their fault, it's my fault, and I'm apologizing for that. So let's move on. I'll start sharing my screen. Okay, I can see my screen now is showing. So last time we met, we talked about all the libraries we have, but yeah, we are going to really look at it. So it's something that is worth memorizing. If you need to memorize it, you memorize it, because this is the foundation of you as a data scientist. I have to be honest with you. If you want to be a data scientist, is ability to understand Python. That's what makes you a data scientist. Yeah. It's good to know tools like Excel, Power BI, Tableau. But knowing all these tools, we call it data analytics. Data analytics. So it's not, knowing that does not make you a data scientist. I'm being honest with you. All these tools we've learned already is extremely important as a data analyst, because data analysts, you deal with a lot of analytics. Analytics are these tools. But when you want to become a data scientist, then you start learning Python. That is how it starts. So that's why I'm trying to pay attention for us to understand these libraries, what it does. Is simple code. They are not difficult. Some of you who are joining data science at this point are very lucky. Why do I say you guys are very lucky? The complexity in data science has been taken away, because within few weeks, if you are very organized, you can start generating code using AIs. You call it natural language processor. All this, we didn't have all this before. So it makes things easy for you to accelerate. So it takes away all the fear, complexity in this. So Python is a powerful programming language.
Sorry, excuse me, sir. Please, sir. Can you zoom out a little bit? It's so tiny. We can't see, sir.
Mm, okay. Let me see if is it
It's okay, sir. It's okay, sir.
okay.
Thank you, sir.
Okay, no worries. So like I was saying, Python is a programming language. I'll be sharing my notes. I have not started sharing. I'm going to share all my notes. As a matter of fact, who is do you guys have uh, a class rep or course rep or bootcamp rep yet? We used to have one. Do you guys have one?
No, sir, we don't have.
Okay, I might maybe Choma forgot. Yeah, because I want someone who will be representing the class, like in a situation whereby if we have a course rep, I like my class to be organized, where we're supposed to have a class, because I told you guys we're going to have a class today. And by 4 o'clock, and you have not seen meeting link, somebody should take it upon himself to check it or check upon Mr. Charles. Are we not having lesson today? We have not received our meeting link. What is going on? We're supposed to have someone who will be doing this before the class. Because if we have someone who is representing people, yeah, the person would have called my attention that I've not posted the link, and I'll just, prompt me to do that. Like lesson notes, I always promise I'm going to post lesson notes immediately. If I don't post it, because at times as I'm leaving the class, I'm joining another class or something can just call my attention, the class rep will be following up. We need the lesson notes, something like that. The video has not been uploaded, something like that. That's why we have class rep. Everybody, but once we don't have a lead like that, everybody will be feeling, well, it's not my responsibility, it's not my responsibility. Things get spoiled. So we're going to look at who is going to represent us, and if you people can organize, I'll talk to Chama to do that anyway. Yeah, I'll let Chama organize you guys and pick someone so that we can work with the person. Is that okay?
Yes, sir.
Okay, thank you. Okay, like I said, data analysis due to its ecosystem of library, not data analysis, data science. Yeah. These libraries provide built-in functions for numeric computing, data manipulation, visualization, and machine learning, making data, I'll make this correction, it's not data analysis, making data science more efficient and accessible. So in this lesson, we are going to explore key Python libraries, or the libraries we are going to explore. We've already spoken about these libraries. Yeah, these are them. Use libraries that is worth memorizing, even if you need to start playing or singing for you to know them. Know that you need NumPy, you need Pandas, you need Matplotlib, you need Seaborn, you need scikit-learn. So these, memorize them, is something you are going to be working with all the time. It's like when we are learning mathematics, some of the mathematics formulas, we cram them. So some of these things, you need to start memorizing them. Try to understand that NumPy is for numerical computing. Just like in Excel, we use functions. In Power BI, we use DAX. It's kind of here. If you don't use NumPy, if we do not install NumPy in your code editor, there is no way you can do anything with numerical figures. You can't do that. It's not going to work. That is what activates the system to work. So that is it. And we know that we'll have tables. Tables will have a lot of numbers. So we deal with numbers in data analysis. So NumPy is extremely important. Yeah, for we call numbers array in Python. So call it array. And Pandas, for you to start manipulating, for you to start manipulating the data set, you must have installed Pandas. They are all very important. Even if you like, install NumPy and you do not install Pandas, it's not gonna work. You have to install all the libraries that you need before they can work, before you can make use of numerical computation, before you can start manipulating. Manipulation is cleaning your data sets, removing misvalues, filling misvalues. Yeah, just the way we clean our table is the same thing, but we need this library in order to structure our data sets. Matplotlib is for visualization. Before you start creating charts, you must have Matplotlib. Yeah, if you remember, if you go to Excel, who can tell me what we use to create charts in Excel? Let's refresh our memories. You remember? Okay.
Pivot charts.
Yeah.
Pivot table.
Good. Pivot table. Yeah. Pivot table. You have to create pivot table first before any other thing. Yeah. Pivot table. And the same thing in Power BI. You create charts as well. In Power BI, you drag and drop, making it so easy for you. Yeah. But in Python, you don't drag and drop. You use code. You use code to execute whatever you need to do. That's the difference between the other tools and this tool. Everything here is piece of code. Then after this chart, we have Seaborn. Seaborn equally help in visualization. Yeah, it's Matplotlib and Seaborn and Plotly. That's what we use for creating visualize, chart, and dashboard. And like I said, scikit-learn is for machine learning, which we are not going into machine learning. Stat model is for statistic analysis and the hypothesis testing. We are not going into that as well. SQL Alchemy is for connecting queries in the database. So it's just for you to, this is if you are going to be connecting your Python to a particular database, so you can be getting data directly from source, is possible. But mostly the data engineers now need to do the configuration whereby a connect system will use this library. They are all code. You will need code to do that, called SQL Alchemy. So SQL is to connect, be a kind of integration with the code editor, so you can access data from there. And Beautiful Soup and Scrapy is for web scraping for data collection. At times we scrape web. So this is what mostly what they do for AI. All this AI we use, they scrape web all the time for updates. Scraping all this large language model, they always scraping the web. So you can equally scrape the web to collect data, web data, and transform it, and then get insights out of the web data. So yeah, all these are libraries. The main important libraries we're going to focus is as for this particular, these are the ones we're going to pay extreme attention. But that's the one we're going to focus on. These four, we need them. So the other ones that are still very important, but they are more of data engineering, connecting, building. Yeah. So, well, at this point, let us not bother ourselves with that. Let's get ourselves the necessary foundation we need before we can start talking about machine learning. So let's look at them one after the other. NumPy, call it numerical Python, library for numerical computation, particularly for handling multi-dimensional array and metrics. Is much faster than Python's built-in is and provides powerful mathematical function. So, like we say, computation, all the mathematics in Python, you know. That's why we call it computer science. Computer science, because of this, is computational aspect of it, computational. So this NumPy is one of the strongest feature of Python because of its computational aspect. It comes with this following feature: efficient multi-dimensional array. Array is numbers. Mathematical and statistical function. Broadcasting, applying operations and different array shapes. Random number generation. Yeah, you can, most of these telecommunication companies, this is what they use, you know, when they want to generate random numbers. You know, most of these companies, phone companies, as more people, they keep generating phone numbers, so just like that. So many of them make use of this Python for this generating numbers. Then linear algebra and matrix operation, that is pure mathematical specialty of it. I'm talking about algebra, linear progression, and the rest of them. Yeah. The way we can use it is a library, is there on the ecosystem. Like I told you the other day, Python is an open source. It's there on the cloud. If you want to use it, you install it. If you don't want to use it, good, but it's there. It's free. You are not paying for it. All you need to know is learn how to use it. Yeah. Even if you like, use it to build a model, AI, or application that's worth billions of pounds. It's your product, it's you, free of charge. You are not giving anybody anything because you use Python and say, because no, it's free. So you install before you use. How do we install it? These are the commands we're going to be using to install all this. You see, like I told you, that Python is not difficult. See, you see pip install NumPy, and it's going to be installed. This is not a difficult code. If you have been using other programming languages like JavaScript, PHP, HTML, you find out that this is very simple code. That's why they say that Python is very simple, but very powerful. It's simple and it works with the speed of light. It loads very fast. It's one of the fastest programming languages. Load very fast. Anything you want to do it is extremely fast. And that's why you see AI. You see, if we are using AI to solve a problem, just query AI, you see within a very short period of time, more especially generative AI is going to generate everything you want to. Even if images, within a short period of time, it's going to generate an image for you. That is it. It's very simple. The beauty of it is that these days you can communicate with Python using natural language. You see, all of us, everybody can use AI, like ChatGPT. Everybody can use ChatGPT. All you need is natural language. You type natural language. It's going to, the way you are typing natural language, behind the same is not working, is not that natural language. It's going to convert that natural language into Python code and get you whatever you want to get. and then transform it into natural language and feed you back. So this is what Python is doing these days, and very, very powerful. So if you want to install, is pip install NumPy. Once you do that, it's going to be installed. And after installing it in your system, in your machine, it's not going to work still. Yes, you've installed it, but it's not going to work until you import it before you can start using it to work. Yeah, very soon we are going to do it practical so that you see all these things I'm saying. So to import, you say import NumPy as NP, and then NumPy will be imported. Once that is done, you can start using it to do your work. Working with NumPy array, that's creating array. Import NumPy as NumPy, then create an array from the list of, like I tell you, arrays, numbers. Create array from list of these numbers. This is the way it works. And then you print, and it's going to show. After doing your work, say print, and your work will then display. So that's the way it's work, and we're going to see it very soon. More especially, this thing is better when we are working and displaying it practical. But the main thing is for you to understand this library. We're not going to start typing up, just for you to understand what this library does, because we're going to use it. And as long as you are going to be in this business, you are going to continue to use it. It's not difficult. Yeah. Basic operation. This is how the code is going to look like. Array equals to np.array, and that is 10, 20, 30. That is array. That is list of numbers. That's what we mean by array. And additional, if you want to add numbers together, that is print array plus array 1 plus array 2 and output. So combine two numbers, this plus this equals to this. Yeah. If this is array and this is another array, so if you want to combine this, is print array plus array. That's how. And if you want to do multiplication, it's going to be array 1 times 2. For instance, you want to times this list with 2. And equally means and sum. Means is average, and sum is addition. It's the same thing, means and sum. So print np mean and print np sum. That's the way it's going to work, just like, yeah. And reshaping and slicing, like matrix equal to np.array. This is reshaping, and this is slicing. If you want to do a slice, or if you want to reshape, it's matrix reshape equal to matrix dot reshape 2 and 3 and 2, and print matrix reshaped. Yeah. very soon. It's not difficult, but we need to still take time to. The first time you are going to see it, it might look a bit overwhelmed, but it's not that overwhelming as it's looking. Yeah. I will equally take us to where we can equally start like as we are in primary school. For those who are hearing Python for the first time, but it's not going to stop us from even working as a data analyst immediately using Python, because by the time I'm done, you see the way we are doing it. We are not going to go back because we don't have time. If we want to start learning it from the scratch, it's going to be a complete boot camp on its own, not even 4 months boot camp, even up to 6 months. If you want to go and start like this, or learning it from array, learning it from ball, we're going to do a bit of bypass all those things, because most of the piece of code or syntax we are going to be using, we are going to use natural language processor to do that, which is going to be faster with help of AI as well. But I'm still going to introduce us to where we can, where we're using AI to learn faster, we can equally use the conventional method, that is traditional method before AI. That's what we're using. Yeah. But it's going to take time. If we want to do it that way, we won't be even able to get to where we are, and we don't have time for that. But it's not difficult. That's one thing I want to open your mind. Okay, let's talk about pandas, which is data manipulation. Pandas is for Python data analysis. It's used for manipulation, manipulating structured data like table or spreadsheet. Is for structured data, not unstructured data. Yeah. So we have what we call series, that is ID label array, and we'll have what we call data frame. That's 2D table similar to Excel or spreadsheet. So most of the time we're going to be using data frame. Data frame is table. Let's just call it table. In Python, we call it data frame. In Excel, you call it table or spreadsheet. So just understand it that way. Still, the only way you can use these pandas is the way you use the NumPy, which is by installing it. pip install pandas. And when you install it, you see import pandas as a PD. And when you finish installing, then you can start performing various functions like manipulation. Here, once installed, you can do this, create data frame from dictionary. Data frame. So you can create a table. When you say create a data frame, means you that creates a table. So this is array. You see this array. If you want to create a data frame with all these, it's going to help you to plot this, and you are going to have this is in a table. Yeah. So if you create this with a table, this will have columns. Yeah. So with this, if you give Python this and say df equals to pd data frame, it's going to turn this into a table. Yeah. And if you want to bring a table that you want to transform, then you need to load from any of these. You can load their table from CSV file, and you can equally load it from Excel. Is df equal to pd read CSV file. Is now going to read the CSV and load the table. But before we load a table, we need to connect the table. We need to know how to connect the table so that Python is going to go and look for where the table is and then pick the table and load the table inside the code editor, which is a Jupyter Notebook. Selecting and filtering table. Say print data frame name is going to, once you say print, is going to print the data frame. Filter row where age is 8 is going to filter and bring the age 8. Filter data frame equal to df age is less than 28, and then print is going to then print. Handling missing data. Filling missing value with a default value. df fill the missing value with a value 0 in place equals to true. So wherever you have missing value, what you are telling it is that wherever you have missing value, you are going to then put 0 where there is any like empty wherever we have empty cell. Avoid having empty cell, because once you have empty cell and you are trying to analyze your data, it's not going to give you a good value. So you need to add wherever you have missing value, put 0. So this is the way you do it. And dropping rows where there is missing value. At times when you have missing value, instead of filling with 0, you can drop the whole row where there is missing value. This is what you need to do, and you drop it. Data frame, drop any in place through, and it's going to drop the whole row where there is missing value. So a missing value is either you fill or you drop. But in most cases, it's better to fill with 0 than dropping. In most cases, as a data analyst, they are not going to even allow you to drop. Before you drop anything, you must even get authorization before you drop. It's equally the same thing in a company. Before you fill any value, you still equally need to get authorization to fill. And data aggregation is calculating the average salary, for example, average salary equal to df salary dot mean. And after calculating, you say print, and it's going to display whatever you have done. And the library for visualization, like we say, matplotlib is for visualization. The same way you install all the other library, that's the way you are going to install the matplotlib. You are going to still use pip install matplotlib. Use matplotlib for charts and visual. And you cannot use it until you import into the data frame. You import it into the notebook before you can start using it. So once it's imported, you can then create a chart. Creating a chart will have, like for instance, will have Y and X axis. You know, even in Power BI, it's always X axis and Y axis. So like years and cells here, and you plot years, sales, and maker 0. So here you say plot X label for years and plot Y label for sales. And then plot title, yearly sales growth, and you plot show, and it's going to display this in a chart. So that's how you plot it. With all these plots, you've already asked the Python to display this in a chart. That's the way you do it. We don't do drag, we do not do drag and drop. We use plots. Once you plot this, all this you see now, once we copy this code now and run it in a Python notebook, it's going to show us a chart of these years and cells. And Seaborn is for advanced visualization. It's still the same visualization where we are going to be creating like histogram and the rest of them. For it to work, we still need to install Seaborn, and after installing Seaborn, we import Seaborn as SNS. And then once that is done, we can then start creating histogram. NSS histo plot data frame age beans 5 can get true, and show is going to then, from the table, it can then display the table or whatever in a histogram. So, and the same thing applies to this scikit-learn for machine learning. So for machine learning, the same thing we install with pip, install scikit-learn, and we import it. into linear regression. And from there, we can start using it for any kind of machine learning and predictive modeling and analysis. So this is just going through what this all this library, how it looks like. It's just a normal introduction. We've not done anything, just for you to see how it looks like. And it doesn't look as so difficult as we might think. Yeah, the first time we are going to see this, it might look so overwhelming, but over time you get used to it. You know, once I'm looking at this, just plot, you see P plot is not a difficult thing. You see this, because if you go to other this, if you see what you can do before you can plot or something, a long code, but this is very simple. It's still plot years, plot cells, years and cell. So you see all this code, still the same thing. It doesn't look like a code to me compared to other programming languages I've seen. So NumPy is used for numerical computing and working with arrays. Pandas is used for data manipulation, cleaning, and aggregation. Matplotlib and Seaborn are used for data visualization. And scikit-learn is for machine learning, which is for predictive analysis. Yeah, predictive analysis is a bit advanced, so we are not going in there. Let's understand these basics first. So all this is better when we start seeing it, doing practical. You know, that's the only way you can see it and believe you can do it. But if I keep saying it, talking about it from here, and I'm not typing and I'm not doing anything, it's not going to sync. So don't get scared. We're going to do it practical. So to do it practical, we need to install these tools so that when I say plot this, you see it as I'm plotting it, and you see it as it is displaying. If I plot this, you see it in just display, and you see how beautiful it looks. So to do that, that is what bringing us to the second topic of tonight, which is tools for data analysis. Last time we briefly scratched it. So, but tonight we are going to look into it deeper to the extent of trying to see how we are going to install them. So, we'll talk about these three tools. One is Jupyter Notebook and Jupyter Lab, and we have Google Colab and Anaconda. And I told you that, yes, you can install Jupyter Notebook directly on your laptop. Yes, it's going to work. Yeah, but it's going to come because you see all these libraries. Whenever you say install, once you install this on your disk, whenever you say install, you are installing from the cloud onto your laptop. Anytime you want to install a library, you are adding more stuff inside your lab, because it cannot operate. Your laptop now becomes the server through which all the computational work happens on your system. So that's why I'm not encouraging anybody to go install it directly on your laptop. It's going to take away a lot of memory. somebody like me that memories is a lot for me. Was, you see, I'm always teaching and that's my charger is trying to. Okay. So let me see here. Okay. Sorry for the distraction. So we're going to just try to understand others, like whichever way we are going to use, whether we are going to use Google Colab or we are going to use Anaconda, you are still going to use Jupyter Notebook or Jupyter Lab. But the only thing is that you are not going to install Jupyter Notebook or Jupyter Lab on your system. You are going to either install it on Google Colab. If you are using Google Colab, it's pre-installed in Google Colab, and Google Colab is on the cloud. So it's not on your system, it's on the Google Cloud. Anything you are doing is on the cloud. It's not affecting your system or your memory in any way. That is the advantage of using Google Colab. Then the one with Anaconda is equally a cloud base. Yeah, a cloud base, but there is a desktop version aspect of it, because the cloud base, if you want to get the full value of the cloud base, you need to pay some fraction of money. But their desktop version is 100% free, but it's optimized that it's not going to take space on your system. And it comes with a big ecosystem. It comes with a kind of marketplace that is going to anything you need is there on, like a market space. All you need to do is whatever tool you want to use. If you want to use Google Colab, sorry, if you want to use Jupyter Notebook, you use it. If you want to use this Jupyter Lab, you use it. It's there. So whichever one you want to use, you use it. And that is the reason why I'm recommending Anaconda for us. That's what I've been using, and that's what our students have been using. So Google Colab is very good, but Anaconda is more robust. Yeah. So Jupyter Notebook or Jupyter Lab is a interactive web-based development environment for writing and executing Python code. It's a code editor. It's meant for executing code, writing and running code. Write, run code in cells, making debug easier. Combine code visualization and markdown documentation in one document. Work with data analysis libraries like Pandas, NumPy, Matplotlib, and others. And installing Jupyter Notebook. So if you want to install Jupyter Notebook, it's going to be pip install notebook. And it's going to install it. Or you have Anaconda. Jupyter is already included in Anaconda. All you need to do is launch Jupyter Notebook inside the Anaconda. Yeah, the good thing is like you're not installing anything on your system. Once Anaconda is there, Anaconda is an application, it's optimized application. Anything more you are installing there is not like adding is just there. Yeah. But if you install Jupyter Notebook, any extra install, like any extra library goes down into your desktop or your laptop. So we are not going to install Jupyter Notebook on our system. So Jupyter Lab is an advanced version of Jupyter Notebook. It's the same thing, but the only difference with Jupyter Lab and Jupyter Notebook is that Jupyter Lab is like the interface. They just modernize the interface to be more friendly. That's the only difference. There's nothing. It's just like a version 1 and version 2 of an application. Let's just say that Jupyter Lab is a modern version of Jupyter Notebook. There's nothing different. It's the same thing. So Google Colab is we call it Google Collaboratory. It's a cloud-based Jupyter Notebook environment provided by Google. It's just for it's a web application, yeah, cloud application, just like Anaconda. The only difference is that Google Colabs is only Jupyter Notebook, but Anaconda carries a lot. Well, you will see Anaconda very soon and you appreciate what I'm trying to say. Anaconda is a big marketplace. So Google Colab is just an environment to make sure that you don't run it on your system, you run it on the cloud. And when you want to save a file, you don't save the file on your system, on your laptop, or you don't save it. So once you save it, it goes directly on your Google Drive. These are the key advantages why some people tend to use Google Drive. So advantages of Google Colabs: no installation is required, free access to cloud computing resources, support Google Drive integration for file storage, allow collaborative editing similar to Google Doc. These are the things. So you can bring somebody, a fellow developer, where both of you can collaborate, or a data analyst, both of you can collaborate and work on the same document. So if you want to use Google Colab, open Google Colab, click new and create, and write and run and you see it. So Google Colab is there. Google Colab. Let's see if we can Google. Google Colab. Yeah, that's yeah, that is you see it. I just type Google Colab, and so if you want to just click launch a notebook, and yeah, you see it now? I've already started using Google Colab here. That's how it's thing. Not difficult. So Google Colab does it, and let's see. So that's how all these things, like you see here, I've typed this post here, and you run. Yeah, because we've not installed all the libraries. Yeah. So that's how you run code here. Yeah. And this is what we call a cell. Anytime you want to run, you run on this. You can add as many as you want. Yeah. And if you don't want anyone, you can just delete it. So, and if you want to do, you can just save. Save to drive. You can save it to your Google Drive directly, or you can copy it to your GitHub. So this is the Google Colab. So it's not difficult to, yeah, what is, it's only, the notebook is built in, it's already working. You have a built-in notebook on this, and that's what we're just using now. So that is Google Colab for you. Yeah. But we're not going to use the Google Colab. So if you want to play around with Google Colab, you see it's just you just type google.colab, or just take it, you can just open it and start using it immediately. As long as you have an account with Google, that's all you need. Start using it right away. So, and finally, Anaconda. So, what is Anaconda? Anaconda is a distribution of Python designed for data science and machine learning. It includes Python. It comes with a Python notebook and Python Jupyter notebook and Jupyter Lab, Spider IDE, data analysis libraries like NumPy, Pandas, and Matplotlib, and others. Why use Anaconda? Anaconda is a pre-installed Python library for data analysis, easy environment management with Conda, no need for manual installation of Jupyter Notebook. You don't need to install Jupyter Notebook manually. And for you to start using it, you just need to download Anaconda. Go to anaconda.com, install, and you start using it. So, yeah, I provided step-by-step for setting up via Anaconda. So you follow this link, and open it. Let's see. So, and it's going to bring you here where you are going to, you see Anaconda. If you sign in, you can use it. You can use the cloud version of it. You can start using it. You need to sign in for you to use the cloud version. Well, like I said, I advise you to get the desktop version. You download it and you start using it. So Anaconda, they have a lot of products for different purposes. But what we're interested here is their environment where we can download their navigator, call it Anaconda Navigator. Yeah. So like what we already talked, one good thing about Anaconda is Anaconda have got a lot of training packages as well. So, talk about data transformation, you see, it comes with all these libraries here, NumPy, Pandas, Jupyter Intake Desk, and for visualization, have Matplotlib, Seaborn, and Plotlib, and then we'll start talking about machine learning, which is scikit-learn and even PyTorch and others, and natural language processing, which that's what we're going to use to be getting most of the code we need. Yeah, so this is where we are going to start from here. I've already installed Anaconda on my system. So you need to sign up and before you can start downloading it. So I've already done that. This is where you're going to, whatever you must sign up. And once you sign up, you download it. It's not difficult. Once you download it, you just double click it and you install it on your system. It's very easy, not difficult. And let me show you how Anaconda is going to look when you download it on your system. Okay. Okay. So can you see my screen?
Yes, we can.
Yeah. You see Anaconda Navigator?
Yes.
Okay. This is what you are going to see when you download it and double click and install on your system. Very simple to install. Once you install it on your system and you open it, this is how it's going to look like. So we have a lot of application built into this Anaconda, so many of them. So many developers, so many people choose to Anaconda because once you get Anaconda, it covers everything. You don't need to be, for instance, I'm here, I'm a developer. I work on Python. I work on different programming languages and different code editors. Like, for instance, this is VS Code. If I want to build a web application, a website, or anything, I'm not going to use, I don't want to use Jupyter Notebook or Jupyter Lab. All I need to do is build my website using PHP, HTML, and the rest of them, JavaScript. This is where I'm supposed to be. Then if I do not have an account, I need to download this. And if I want to do some work on data analysis, I come and download this again, or I download this again. But if you get an Anaconda, you have all this in one place. All you need to do is just launch them, and you start working. You know, all of them here. You see all these ones. I'm using them. This Anaconda Toolbox, Anaconda Cloud Notebook. I'm using VS Code. I'm using Anaconda PowerShell. I'm using Anaconda Prompt. I'm not using PyCharm. I'm using Jupyter Lab, and I'm using Jupyter Notebook. All of them inside Anaconda. So that's why I use Anaconda. So everything you want is here. So once you download it, install it. Once you download it and install it, come here. This is it. It's here. Once you install, you can launch. So if I'm launching it now, it's going to go and open on my browser. On my browser, I'll start using it. So let me check my browser. So it might take some time before it launches on my browser. Once it launches, you come and see it here. You'll be on my browser. It's going to take time before it launches. And that is it. I'll start using it. So it's not difficult to set it up. So before you can download anything here, you need to sign up. You need to register with Anaconda, and then you can be able to download the tool on your system. Without signing up, you will not see anything. You will go into some people say, I cannot. You need to sign up, have an account with them. If you have an account with them, you can equally start using their cloud version, but it's limited. So the Anaconda I've launched is going to take time for it to come. So this is it. The one I'll launch. Let me see. Launch it again. So why it's not coming up. I need to reinstall my laptop before, because this Anaconda has been open for some time now. So other things we can do here in through Anaconda. Anaconda has its own community, and Anaconda is equally got learning, Anaconda Learning. On here, Anaconda Learning, you see so you see a lot of things you can learn here. You see introduction to SQL, machine learning, They have a lot of things here. Anaconda. Okay, my Jupyter notebook is my Jupyter lab is launching. So it's still loading. Can you guys see it coming up?
Yes, I can see.
Can you see anything? Can you see my screen?
Yes, I can
Yes,
see.
you can see it. You can.
Okay. So once you get Anaconda, just like I say, launch. If you launch it, this is what is going to open for you. It's going to open something like this here. And it's going to localhost 8891/lab. So that's where I'm using Jupyter Lab. Yeah. So, and this is here, you can click and you are going to launch this, or you can click another one from here. And okay, let's it's just trying to load and load and load. So this is my work. The last class I had, I saved my notes, everything here. You see it here, and all the work we've done here is here, and it's yeah, that's all the work we've done, and all the table we created. Everything is still saved for us. So saved, and yeah. So yeah, even our dashboard is still, it saved everything for me. So yeah, that's it. This one is still loading. Read it again. So if I want to launch a new window, I'll just come here. I'll launch another notebook. But this, I'll launch another notebook here. Yeah. See here, and I'll come here and I will launch it. It's called Notebook. I'll launch a notebook. Yeah. I can equally close it. I can launch as many notebooks. Let's call it notebook. standard way. So I have to know this is the notebook for the last class. I can create another notebook for this class and start teaching with another notebook. And so that's why I'll call it notebook. Yeah, so well, the first thing you need to do is head over to this place. Yeah, head over to anaconda.com/download and get started from here. Once you finish signing up, you are going to download the Anaconda. Once you download it, double click and it will start installing. Once you finish installing, you get something like this. That is Anaconda Navigator. So your Anaconda Navigator, from Anaconda Navigator, you will see all these small applications in your navigator. Whichever one you want to use, you launch it. For instance, I'm using Lab. You see, once I click launch, it's going to open a notebook, the Jupyter Lab on my browser, and I'll start using it. If I want to use VS Code, I launch, it's going to open it, I'll start using it. Anyone I want to use, I'll just launch. So that's the purpose of Anaconda, and yeah. So that's the assignment, setting your own up. So we are going to be there in the platform, waiting for everybody, following up as everybody is trying to install. So by the time you struggle from this night, tomorrow being Friday, struggle on Saturday, struggle on, before you finish by next week, your notebook, your Anaconda should be running. So we are going to support you if you are having struggles. So if it's not working, you let us know from the WhatsApp platform, and we know we're going to come for support in any way we can. So that's it, and that's where we're going to stop for tonight. There's nothing much we can do. This thing is better learn it practically. I think the only thing that remains is for us to get it installed so we can start doing it practically. Yeah. If you have any question, I can take your question. Okay, Sterling.
Okay, so good evening, Mr. Charles. Thank you. So there are two I'm seeing here. I tried to download, but it's showing graphic installer. Is that what we're supposed to download? Under Anaconda distribution. Another, or are we supposed to download the navigator? What are we supposed to download?
I said Anaconda Navigator.
That's what we're
Navigator
supposed to
is,
download.
if you see, let me share my screen for one more time so that you see it clearly. Yeah. Can you see my screen now?
Yes.
Can you see Anaconda Navigator?
Yeah. Is it the same as Anaconda AI Navigator, or is it just Anaconda Navigator you're supposed to download?
Anaconda Navigator. And which window or Mac, make sure you're on you select the one for your operating system. So it's Navigator, and yeah. All right. Thank you guys for tonight. I know we've overshoot our time. So we combined two topics that are supposed to be two lessons this night. So let us know your progress on the platform, and yeah, we'll take it from there. So thank you for joining, and have a peaceful night's rest.
Thank you, sir. Good night, sir.
Thank you. Good night.